Alright, so let's talk about fluid kinematics and racial forces. So fluid kinematics is very simple, right? So after you learn to call this is the x direction, this is the y direction, this is the z direction. Here, here, here. So in this point, right, this is one, 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 right? It goes right to the x, goes up, and goes it doesn't go up, doesn't go up. Sorry, it goes this way, and then goes that way, and then goes up to the z direction. And this is where the precision says this is very simple. And then if you get collided, right, you do this equation, right? 2 meters per second, 1 meters per second. So you got this equation right here. So all these newtons, right? The newtons must equal to that newton. Alright? So basically all you do is 11 times and not times. So you do is find an equation, right? That says the newton equals to that. Alright? Said the newtons equals to each other. Because you already know the velocity. So now we can do this faster than me. Alright. So I'm gonna start 11. I'm gonna set that. I'm gonna pick a random number. So 11 divided by x equals to 6. So divided by 11. And then pick 12. So 11 x equals to 6. 12 here, and 6. And x equals to 6. Oh, times 6. This is gonna be half here. It's gonna be 6 divided by 11. So ratio, and this is gonna be 6 divided by 11. So that's gonna be a half. It's just 6. And then you find the ratio in the 3D kinetics and you do a bunch of equations. So this is how the equation is gonna look like. Alright. So do like basically you put the velocity here. You see all these this mathematician physicists that laid out the equation. You say this thing's going 2 meters per second, right? Alright, 2 minutes per second, then 1 minute per second. Alright, then basically like subtract that by fx or and then bx and cx. It's basically f equals ma. Alright, that's equal to ma. And then you take an integral. Alright, but you write out velocity in the force. So you basically do this, right? Basically it's velocity minus velocity. But you find the ratio of n to find the velocities. You find the ratio of n to find the velocity. So that's 3D kinetics. I'm going to teach you about something very simple. Let's say you have a magnet. So, okay, I'm going to split the straight here. You have a magnet. Alright? Negative, plus. That thing attracts here. Everything attracts the metal. Right? And this is right here. So, you can do that with 3D kinetics. You can use that with 3D kinetics. I don't remember much about EM, but vector fields are the same. So that thing has a pulling force. Right, they pull some things in. Right, showing the magnet is creates the velocity. So you can do that with EM. But I'm gonna teach you something very simple. Alright. So every physicist likes to have something different. Right? The reason why kinetics, 3D kinetics is different from EM, different from quantum, because they need to differentiate the two. That's why they have different brackets, because math has different brackets. So basically, right, you do this pulling equation, right? So I'm gonna go to my laptop. I've got some equations. It's just got 50 minutes. So I'm gonna have to send it. Beautiful, 9 minutes. I'm gonna got some equations. So you remember Kirchhoff's law? Yeah, Kirchhoff's law, boys. So Kirchhoff's law. Alright. So think everything is negatives and positives, right? So magnetic force can pull and push. Alright? And then kinetics, can push and not pull. So the magnetic force is the pulling force. So but right now I'm thinking more mechanical engineering. So let's say we're gonna do some before we start here. We're gonna do some idea play. So this is the kinematics, kinetic, kinetic equation. We're gonna do some idea play. Now that all mathematician knows all equations. So here, starting with tax, right? So let's say you have a tube, right? Starting with tax, this butt, starting with tax, this goes here. Alright, so imagine you got like lots of dots in a circle, lots of dots the whole time in a circle, and you push it here. Put one dot here. I'm gonna show you a very interesting trick. Alright, so imagine you have interesting weapon, alright, but you can actually calculate this. This is how computers calculate what you connect. Just point the dots, right, and then push it, right. Now vector fields, right? It's just not even pushing fields. Everything's like kinetic equations, right? Starts with kinetic equation. The reason why magnetics have a different, like this will not be 50 minutes. Have a different magnets have a different. EM have a different bracket system, and then quantum has a different bracket system because they behave differently than kinetics, and the EM different than everybody. But technically they behave the same because they live in laws physics. But they have different roles. So okay. I'm gonna do a very long equation here. I'm gonna do a picture. It's just draw. It's gonna be very tricky. Alright. I'm gonna put a magnet right here. Alright. It's only has a really strong pulling force, everything going here, and then stuff for going here. All you're doing, alright, is accounting. I call it physics accounting. But see, it's time. Yeah. Time for you to plug it in, man. Alright, so see you in the next. Thank you.